Quantum electrodynamics, QED, is a branch of physics that combines electromagnetism with quantum mechanics, focusing on the interactions of particles such as electrons, positrons, particles with positive charge, and photons, particles of light. It serves as a crucial framework for understanding and explaining both matter and optical phenomena. It applies the principles of quantum mechanics to the realm of electromagnetism, describing how charged particles interact within matter. The theory details interactions between electrons mediated by photons and incorporates the probabilistic nature of quantum mechanics. In conjunction with general relativity, is used to describe the behavior of charged particles at relatively high energies. Developed during the mid-20th century by scientists such as Richard Feynman, Julian Schwinger, and Shinichiro Tomonaga, quantum electrodynamics stands as a cornerstone of quantum physics. It exemplifies the quantum nature of electromagnetism and represents a significant intersection between various branches of quantum mechanics. Quantum electrodynamics, QED, is a theoretical framework that integrates the foundational principles of quantum mechanics into the realm of electromagnetism. It addresses how particles with electric charge interact within matter. In this theory, the behavior of these charged particles is described by incorporating the probabilistic nature of quantum mechanics. Let's break down the key components of this description in more detail. Integration of quantum mechanics and electromagnetism. It combines the principles of quantum mechanics, which govern the behavior of particles on the smallest scales, with electromagnetism, the force responsible for interactions between charged particles. Particle interactions within matter. It explains how particles with electric charge, such as electrons and positrons, interact within a material or vacuum. It provides a framework to calculate the probabilities of various interactions, such as scattering and annihilation, that occur when these charged particles come into contact. Photon-mediated interactions. At the heart of it lies the concept of photons as carriers of the electromagnetic force. Photons are virtual particles that mediate interactions between charged particles. For example, when electrons repel or attract each other, they exchange virtual photons to convey these forces. Probabilistic nature of quantum mechanics. It incorporates the probabilistic nature of quantum mechanics. It describes the behavior of particles not in terms of definite trajectories, but rather in terms of probability distributions. This means that we can predict the likelihood of certain outcomes, but not their exact paths. High energy behavior and general relativity. It is particularly useful when describing the behavior of charged particles at high energies. When combined with Einstein's theory of general relativity, it contributes to a more complete understanding of particle behavior in extreme conditions, such as those found in high-energy particle accelerators or astrophysical phenomena like black holes. Overall, quantum electrodynamics is a sophisticated theoretical framework that allows us to accurately predict and explain the behavior of charged particles, taking into account both the quantum mechanical nature of particles and the electromagnetic forces that govern their interactions. It has been confirmed through numerous experimental tests and calculations and is considered one of the most successful theories in the history of physics.